Okay guys, so title your notes Similar Triangles. This lesson is going to feel a lot like the congruent triangles lesson, but it's going to be a lot less complicated. So remember, congruent triangles, our whole goal was let's prove them guilty of being congruent. And I don't want to check every side and every angle, so let's develop some shortcuts like side, 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 angle, side, angle, angle, side, and HL. So you remember those 5? Well, to prove two triangles guilty of being similar, we're going to come up with some shortcuts, but there's only 3 of them. So it'll be a lot more simple this time. So the title of your notes is Similar Triangles. And then I'm just going to throw a lot of triangles on the board, and we're going to talk about whether we think they're similar or not. Keep in mind, everything we learned today only works on triangles. You cannot apply it to other polygons. All right. So I wanted to look at these triangles real quick, kind of a collection of different triangles. Let's see if we can determine if some of these are similar to each other. So stare at those for a little while. All right, so who thinks they see a pair of similar triangles?
I do.
Okay, tell me the numbers and we'll talk out loud about them.
1, 8.
1 and 8. So let's look at those. So remember, from similar polygons, we had to check that all the angles were, what? Congruent, and all the sides were proportional. Now, what we're going to learn today is you don't have to check all, 12 of those things. But if we look at 1 and 8, are all the angles the same? 35, 35, 35, 35, 110, 110. Check on the angles. Are the sides proportional? So 25 divided by 5, 5. 25 divided by 5, 5. 50 divided by 10, 5. Okay, so the angles are congruent, the sides are proportional. So triangle 1 is similar to triangle 8. What else you got?
3 and 4.
3 and 4. All right, so angles are congruent, sides are proportional. Let's check. 12 divided by 3 is 4. 15 divided by 6, ooh, nope. Oh. So the angles are congruent, but the sides were not proportional.
5 and 6.
5 and 6. All right, so is it enough that all the angles match and we know nothing about the sides? That's part of today's lesson. Yeah, it is enough. But it is good to question that first and say, ooh, do we need any sides? Because angle, 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 that sure was not a congruent triangle theorem, right? That didn't work for congruent triangles. Ooh, but maybe it'll work for similar triangles because they work differently. Okay, what else?
2 and 7.
2 and 7. That's kind of scary because we don't know any of the side lengths. Do you feel okay about it? Back it up.
It's equilateral, so all the angles are equal.
Well, there you go. They're both equilateral triangles. So all of the angles are 60. All 6 angles are 60 degrees. So all the angles match and the sides are definitely going to be proportional. Double tick mark divided by single is going to equal double tick mark divided by single every time. There's one more thing that you guys are not seeing. There's one more triangle that can get added to this list.
3 and 4?
No, we already checked 3 and 4. So there's not a pair that can get added to this list, but there's another triangle that can be similar to one of these pairs we already listed. There we go. We can add 3 to the 1 and the 8. It's crazy, but it's true, and we'll talk about it. Ready? So 1 is similar to 8 is similar to 3. Let's take a look. Look at what they have in common. They all have 35 in common. Now, if we look at the sides surrounding the angle, I'm gonna approach it a different way than I did on the other ones. What's 3 doubled? 6. What's 25 doubled? 50. What's 5 doubled? 10. So what would we call that one? Like if I called 5 and 6 angle, 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 if I called 2 and 7 side, 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 what would I call 8 and 3?
Side, angle, side.
Ooh, there you go. So is that enough? Is two sides in an included angle enough to prove them similar? And that's what our lesson is today. So that was a good exercise. Right there for you, there are the 3 theorems that will prove two triangles guilty of being similar. Please write them down. Angle, angle, similarity, side, 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 similarity, and side, angle, side, similarity. So the squiggly stands for similar. Why is that first one just angle, angle, similarity? Why didn't they put angle, angle, angle? There's 3 angles in a triangle.
Because the third one would always be subtracted from the 180.
The triangle sum theorem, very good. But don't use that on side, side, side. Don't just check 2 of the sides and assume the third one falls in line. Do not do that. So make sure it's angle, angle, but it's side, side, side. We also want to make sure we always put the similarity symbol. If we don't put the symbol, then you've proved them congruent, and that is not what you were trying to prove. So never forget the symbol. All right, we're going to try some examples, and then our lesson's over. Easy lesson today. We're going to start, I'm skipping all of those because you don't need to write them down. We're going to start here. Determine if the triangles are similar. I'll give you a minute to sketch it quickly. So the first thing that I would do is say, all right, I've got 3 options. Well, technically I've got 4 options because you can write none or NP as one of your choices. But of our 3 options, which one does your gut tell you this could be? Obviously.
Side, angle, side.
Okay. So in my mind, this is either going to be side, angle, side, squiggly, or not possible to prove them similar. Okay? So really now we're down to a 50-50 chance. What do we need to check?
Proportions.
Good. We need to check to see if the sides are proportional. The angle's obvious. I mean, we have got ourselves an angle. That's pretty easy to see. Let's make sure 10 is to 6 as 15 is to 9. There's no certain order you need to set these proportions up in. I chose to start with 10, but there's no reason I had to start with 10. Could have started anywhere. All right, so true or false? 10 is to 6 as 15 is to 9. True or false? True. You can do that by dividing each one. I got 1.6 repeating, 1.6 repeating. Or you could do that by cross multiplying. You'll get 90 either way. So, what is the answer to the problem?
They are similar.
Yes, they are similar by side, angle, side, similarity. Try this one. Now, if you notice on this one, there are no arc marks. We don't know which sides go with each other. There's no similarity statement. Does M go with D? Does M go with O? I don't know. So when there's no markings to help you, it's very, very simple. You take the sides and you put the smallest over the smallest, the medium over the medium, and the large over the large. That's how you determine the corresponding sides. So, smallest and smallest. 6 is to 14 as medium, medium. 9 is to 21 as large, large. Okay. You can cross multiply a couple of times if you want, or you can just divide each fraction, or you can reduce each fraction. It's totally up to you. I usually just divide it and write down the ugly decimal. 0.428. 9 divided by 21. Yay! 0.428. 12 divided by 29. Oh, no. So we're 100th off or more. So triangles are not similar. You have to check all 3 sides. So it is not possible to prove these triangles similar. What do we know here? Is there any information we're allowed to add to this picture?
That's the mid-segment.
Ooh, it is the mid-segment.
The angles are even.
I heard reflexive property. That one's the most obvious. It is the mid-segment, and I love that that you notice that, and we could do parallel lines, and we could do all sorts of things, but to me, the most obvious, like the most direct way to get an answer is those two triangles are sharing an angle. That angle is congruent to itself, reflexive property. So now, we notice tick marks mean sides. So we've got ourselves a side, an included angle, and another side. We don't have to know the length of those sides, because we know that one tick mark over the sum of two tick marks is going to equal double tick mark over the sum of the double tick marks. If you're a little leery and you're like, ooh, I don't know, are those sides proportional? You could just make up numbers. You could say, you know, this is 2 and this is 2, and I'll make this one length 5, length 5. So you could say for this triangle, 2 is to 4 as 5 is to, what would this whole thing be? Oh, it would be 10, and it's obvious that those are going to be proportional. They both reduce to 1/2. So if you want to pick numbers and try it, you can, but most of you could have looked at that and known that those are guilty of being similar by side angle side similarity. All right, next one, determine if the triangles are similar. So this one starts with like almost no evidence at all. All we have are some arrows, and those arrows mean parallel lines, of course. So we know that these are parallel right here. Parallel lines tell us nothing about the length, so there are no tick marks that we're going to be adding to this picture. But if you remember, parallel lines, when cut by a transversal, we get all these cool angle relationships if those lines were indeed parallel. So I can mark these angles because corresponding angles are congruent when lines are parallel. Also, just like the last problem, I can mark this shared angle, reflexive property, and I am done. The work is over. These are guilty of being similar by angle, angle. I don't even need to mark the third one. Determine if the triangles are similar. Well, right now, those angles don't perfectly match. 40 matches 40, but 60 doesn't match 80. Don't stop right there. Use triangle sum theorem. Find the missing angles. Oh, now they match. Even though I have 3 angles, I still call it angle-angle similarity. You don't add 3 A's to it. That's not the name of the theorem. The theorem is angle-angle because it's a shortcut. So don't add another A to that. Hot dog. We haven't used this in a while. It's a little rusty, but we have the good old vertical angle theorem that we can employ here. So arc, arc, and done. Guilty of being similar by angle, angle. Ooh. So we're going to go ahead and assume that they're talking about the 2 triangles created. If it was on a quiz, it would have to tell you which triangles we're talking about. Is it the large one and the small one? Is it the medium one and the large one? We'll go ahead and compare A to B for our purposes here. So there's something we can assume right there. So it's looking like side angle side. I've got 2 sides, included right angle. 2 sides, included right angle. But let's make sure they're proportional. Now, a lot of students like to redraw this because it helps them know which sides they've used. I highly recommend, if you're having trouble seeing this, you redraw it because it's going to show you that you have to use that 9 twice. Highly recommend the redrawing. All right, so we set up a proportion. Small over small, is it equal to large over large? And that reduces to 1/3. That reduces to 1/3. Awesome. So they are similar by side angle side similarity there. So drawing them separate when they're sharing that side really helps you organize those side lengths.
Miss Chances.
Yes.
I want.
So this is the last one we're going to do, and I really like this one because it's important to know you can't just start setting up proportions and cross-multiplying whenever you feel like. The shapes have to be similar to begin with before you can use the sides being proportional. So I like how this says first, determine if the triangles are similar. If they are, then you can set up a proportion to solve for x and y. But don't just start assuming they're similar and setting up proportions because it doesn't work when the triangles are not similar. So are these similar? Well, we've got our good old vertical angles. And then we've got our parallel lines and a transversal. So it's important to be able to find those missing connections that were kind of in the picture but hard to see, kind of camouflaged. Okay, we feel good about it. Now we know they're guilty of being similar by angle, angle. Now I can set up a proportion. So I could say 15 is to 10 as, okay, I know these went together. That one was easy. Now, which one does 12 go with? Do I do, well, it's kind of obvious. I'm going to put it with a variable, right? But if you didn't know, 12 is across from a double arc, and x is across from a double arc. So I know 15 is to 10 as 12 is to x. Likewise, 15 is to 10 as y is to 8. And you can cross multiply those and find those answers for yourself.